Hello, guys. Can you guys hear me?
Yeah.
Okay, sweet. Wait, I need to set up the audio. All right. Okay. So, as you might see in the group, this is our okay, this is technically, oh, Hannah's here. Nice. All right. So today is our technically like the first lesson after the 4 weeks. And we're just gonna continue. Wait, I think I should go through the calendar or like the material that we're gonna go through first. Oh, where is it? Oh, here it is. All right. So this is the official like official content or like instruction, not instruction, um introduction to the course. So yeah, the important thing is the time. Time will be Sunday this time. So it'll be 6 in New Zealand, 4 in Sydney, 2 in China. This time will not change for this term, but for because of daylight savings, it will be changing, I think, in September. But that's not this term. And this term will have 7 weeks, and we'll have public holidays and school holidays and everything. So this lesson will not go on for holidays. Okay, it will only be for the school weeks. So today, which is the 18th of May, we are doing more exponentials, continuing from last time. And exponential is also kind of like functions, so exponentials and function. And if we have time today, we can do some logarithms, but like very basic ones. But mainly, I think today I'll be focusing on practicing the questions and also teaching you guys what the natural number is. Because last time we kind of rushed through it, and some of you told me you didn't really get what it is. So we'll just spend time doing what this is, and then yeah. And next week we'll be doing a thing called binomial. So if you guys have learned, if you guys have learned this before, when you expand a plus b to the power of 2 squared, this is a squared plus 2ab plus b squared. And if you keep expanding this, let's say power of 3, you're gonna see this is like a cubed plus 3a squared b plus 3ab squared plus b cubed, okay? And when this term gets very, very big, there is a pattern that you can see, and that is what binomial is, okay? It's very useful, very, very useful. Probability and statistics. And then we'll do sequences. This is the first chapter of IB. Hannah have done this before. And yeah, we'll be focusing on practicing more questions. So it will be useful. For Ryan and Adriana, I believe this will just be kind of like new stuff. But for Hannah, there'll be more like revision. And then I think it'll be very useful as well in terms of doing more practices. And then we'll do more functions. Because last time we barely touched domain and range, right? We didn't really do that much domain and range. This time we're gonna like finish domain and range. We're also gonna introduce a concept. We're also gonna introduce transformation and inverse functions. These two are very important. Last time I believe we didn't do inverse function at all. So this is gonna like finish off functions, hopefully, if we have enough time. And yeah, and then quadratics as well. Last time I believe we didn't really do too much completing the square. I'm not too sure, but like this time we'll be focusing on practicing a lot of algebra with quadratics. Okay. And trigonometry, we haven't done it, but it's not new to you guys. You guys have probably known SOHCAHTOA. SOHCAHTOA. We're gonna do this, and if we have time, we're gonna do unit circle, but maybe not. And the revision is just gonna depends on how we do in the first 6 weeks. We're gonna like do whatever is needed. Okay, so sounds good. Any questions?
No.
Okay. I feel like I feel like by doing this, we kind of one thing I'm thinking is that we kind of rushing through everything. Like it would be too much, like especially for the last 2 weeks, 4 weeks, I think it's too much teaching rather than practicing. So in the meantime, I'll try focusing on doing more practices rather than going into the deeper level. Okay, because when you do it at school, you're gonna learn everything. like systematically. Right now, yeah, I'll be focusing on more practice questions. And also I'll be giving you guys some homeworks. I think it'll be like half an hour at max every week. I don't want to give you guys too much homework, but it's important you practice the stuff that we learn in class, so you actually memorize it. What else I have to go through? Yeah, that's pretty much it. All right, let's get started. I'll still be teaching using the same textbook. Uh, oh, by the way, when I'm teaching using the textbook, you guys cannot access the textbook online. It's because there's only one account. If in the future, if we need it, we can buy more textbooks. All right, so before we start, I'm just gonna do a quick revision on what we did last time with exponentials. So I'm just gonna write out the left-hand side of the formula, and you guys can send me the right-hand side. Or you guys can just write on the paper like the right-hand side of the formula, okay? So for the first one, we have, let's say, x to the power of a times x to the power of b equals what? You guys can write out the left-hand side on maybe on your book and then as a practice.
Wait, where do we write this?
Oh, just on your own, just on your own. You don't have to like send it to me. Just like write it on your own in your like notebook or whatever as practices. This is what we did last time, okay? And if there's any confusion or if you guys forgot any of those or like if you guys forget any of the reasons behind it, feel free to tell me. I'm happy to go through it again. When you finish, just tell me in the chat, just say finished. You don't have to send it to me because sending this kind of stuff is kind of difficult, right? Okay, Hannah, Adriana finished. Brian, we are waiting for you. No rush. Take your time. All right, Ryan's finished as well. Nice. All right, okay, there's five of them. Okay, who wants to go first? Adriana, what did you get for the first one?
X to the power of a plus b.
Okay, Hannah, what did you get for the second one?
X to the power of a minus b.
Okay, Ryan.
A times B. X to the power of A
Okay,
times B.
Adriana.
Uh, X to the power of negative a.
Nice. Hannah.
X to the power of 1 over a.
Nice. Who haven't got another chance? Okay, Ryan, I'm gonna test you on something else. If we have x to the power of m over n, how do you simplify this to a root without a fraction?
Um, Square root M over N. Oh no. Square root N. No, square root X to the power of N.
No, it's
And
okay. Take your time. Take your time. No rush. Everyone else can think about this as well. If you know, you can tell me if you can answer. Oh,
Wait,
so
how do
yeah.
you put the N on like what is it called when you have it where A is? I forgot what that's called.
Some where a is eighth root. This is called eighth root.
Oh, the nth root of x multiplied to the power of m.
Nice, nice. So you can try to break this down into two parts, right? You can break it down into x to the power of m and then bracket 1 over n. And you just treat the inside as one whole thing. So don't worry about x to the power of m. And the 1 over n turns into nth root. Okay. By the way, just fun facts. Roots, the notation is because the roots goes down very fast. So technically the roots notation is like this. This is the proper original root notation, okay? Handwritten root notation, and your n should go here.
Damn.
Okay, just fun facts. Since we talking about this, I might Google because I don't know. I was pretty nerdy with math in high school. I was like, root notation, handwriting. Okay, something like that. Nope, that's not it. Um, notation. I don't know if I can find it anymore. How to write notation. Oh, come on. There's no handwriting ones. Okay, if I can't find it, then screw it. Oh, I can't find those ones anymore. Algorithms have changed. All right, whatever. All right, so that's the stuff we did last time. Oh, also anything to the power of 0 equals 1, okay? Don't we forget this. So yeah, once you know all those rules, you can pretty much do all these type of questions, right? That's the ones we did last time. I believe we haven't done nice C last time. Okay, we haven't done nice C. All right, in that case, we can start with nice C.
Where is that?
Wait, I'm gonna take a screenshot. We did do nice B, and yeah, I believe we did. Okay, we did do that. We haven't done nice C. Okay, and then this is a good place to start again. All right, cool. All right, guys. So now we do this one. Just do them one by one. You don't have to. Wait, is it easy to send it to me? Oh yeah, I believe it's quite easy to send it to me. So okay. Oh, guys, I think do something like this. So in the chat, for example, the first question is obviously 4, right? You're gonna send 4. If I send 4 right now, right, and then can I edit this? Oh, I can't edit this. Oh, that's bad. Oh, okay. Is there an organized way for me to check all the answers? All right, in that case, I think we'll do this. Everyone do all the questions. If you have any questions, you can ask me. But when you finish all the questions, tell me when you're finished, and when everyone's finished, I'll explain everything at once. Okay? I think that's quite effective. Otherwise, checking every single answer is going to be too much checking answers for me. All right, so do part 1 first. So the questions are not meant to be too hard. It should be like the question should be like doable. It should be like more like practice. In the meantime, if you guys get stuck on any, you can just ask me or you can just skip that one. Okay? All right, so how's everyone doing? Which question is everyone up to?
I'm on G.
Okay.
I'm on H.
Hannah? No rush. Take your time. Okay. I just wanna make sure you guys are doing okay. How's the difficulty? Too easy or too hard? I think it's okay, right?
Do we have to do two as well?
No, just one. Are you finished?
No.
Okay. Okay, that's the rough time is pretty much okay. I think like 30 seconds every question is good time. Oh my God. Okay, how's everyone doing? Okay, in the meantime, I think in the meantime, I'm gonna start explaining some of the previous questions. Uh, okay, I think everyone now send me question for A, like send it one by one. Or
4.
maybe just shout it out. 4, okay. A is 4, okay.
Oh,
That's
no,
2.
I thought you said 4A.
Oh yeah, 4. Yeah, A. What about B? What do you guys get for B?
6.
5.
Okay, interesting. We have two different answers.
Oh, wait, let me count.
Is that not 6?
I got 6.
You just count the number of zeros.
Yeah.
What, but
Okay.
isn't.
You can start from an easy one. Let's say, for example, 10 to the power 1 is 10. 10 to the power 2 is 100, right? 10 to the power 3 is 1000. You're gonna realize that the power, like slowly,
Oh,
this is what we call
I counted
induction.
a less 0.
Yeah. This is kind of called induction. It's like we want to understand the reasoning behind it, right? For example, very basic one, 0.001. What is this to the power of 10? Anyone tell me?
To the power of -3.
No. Oh wait, yeah,
Yeah.
-3. Yes, right. Yeah,
Mate.
yeah, yeah.
Fuck.
Yeah, so I was saying that, see, here we have two zeros, but it's a -3. So um why is it true, right? You want to know the reasons behind it. And in this case, the reason behind is the decimal point moves 1 to 3 times with each 10. So there's you're dividing 10 3 times or -3, okay? Same as dividing on 10 3 times. Maybe I should write this in the proper way. Right. So you want to know the reasons behind these kind of stuff, right? 10 -3, or the same as dividing 10 3 times. Okay. Divide 10 3 times, something like that. And yeah, when you have a negative power, you can kind of think about it as dividing. Okay. But putting it in the power makes it much easier to operate, because putting it in the power, like negative power, everything becomes multiplying each other. And that's multiplying is a really good thing. It's a really easy thing to deal with. All right, someone shout out, what did you get for C?
5.
5.
5, okay. To the power of, okay, to solve this normally, we just be like 2x plus 1 equals 64. But what is 64? 64 is to the power of 6. And we know both of them are positive, so we don't have to consider like the negative powers, okay? Uh, sorry, not negative powers. We don't have to consider the negative possibilities. Like for example, we have x squared equals 64. In that case, there are two roots, but in this case, we don't have to consider it because this is always positive. In that case, x plus 1 equals 6, x equals 5. Adriana, did you get all of those correct?
Yeah.
Okay. Adriana, what did you get for D?
2.
Okay, let's see if this is correct. Okay, 2x minus 1. We want to start by converting 27 to a power of 3, so 3, 3. So 2x minus 1 equals 3, so 2x equals 3 plus 1, 4, x equals 2. Nice. Blah, blah, blah. Everyone else got the same answer?
Mm.
Okay.
Yeah.
What about for E? Just shout it out, anyone.
Half.
Anyone have different answers?
No, I got a half as well.
Okay, because we're aiming for power of 0, right? Because we know 1 is 3 to the power of 0, so we
Wait,
can remove the bit. Yeah,
Wait, I don't think I did it right.
it's okay. It's okay. Um, it's all about the process. It's all about the learning process. Did you start with this?
That was what?
Sorry?
Start with what?
Did you start with 3 to the power of 0?
No.
Oh, maybe that's the problem. Because you think about, oh, what power of 3 gives you 1? And that's 3 to the power of 0 gives you 1. In that case, you go 1 equal 2x and x equal half. Okay? Tana, does that make sense?
Yeah.
All right. Does everyone finished, or do you have a few more questions to go?
I'm on the last one.
Okay, yeah. Finish everything and then tell me, and then we'll explain the remaining questions.
Michael, could I go to the bathroom?
Yeah, sure, sure.
Wait, Michael, for question,
Yo, Jay?
yeah, let me just
Yo,
type with you, because right now I'm up to like,
convert the square root to a power, and then you'll be chilling.
that's what I did, but
Okay?
since now they both have powers, do I have to multiply them together since it's
I
like,
don't get what you mean. Multiply, yeah, yeah. Use the
okay,
formula. Multiplication becomes addition in the power. Something like that.
okay, I finished.
Nice, nice. In the meantime, you can take a break or you can do two. Up to you. We'll be doing two afterwards. You can take like 2, 3 minute break. All right, Adriana, finish all the other questions, and then when you finish, please tell me.
I didn't understand the question. Can I leave it blank?
Yeah, sure, sure, yeah. All right, Hannah and Adriana, how are you guys doing?
Wait, are we moving on to 2?
No, I'm just finishing off one. When you guys finish, I'll explain the remaining questions.
Oh, I was already done.
Yeah.
Oh, oh, I thought you guys to tell me. I was still waiting. Okay, what did you guys get for F?
Oh, I got 4.
Hannah?
Yeah, same.
Okay, so divided by 3, you should get 16. And same as question 1, x equal 4. What about G? Anyone?
-5.
Yeah.
All right, so 64, this is 1 over 2 to the power of 6. Okay, no, maybe, sorry, maybe do 4 to the power of 3, because on the left-hand side we have a 4. And we have 4x plus 2, and this is 4 negative 3, okay? This might not make sense intuitively, but mathematically we just, again, drop the power because we know both sides are positive, and the graph of exponential kind of looks like this, okay? Yeah. One thing we got to consider is that, okay, are there any ambiguities or like potential positive, negative, those kind of stuff in this? But exponential function tells us, okay, how do I do this? Now, exponential function, in terms of functions, this is what we call one-to-one function, okay? It means one input corresponds to one output, and one output corresponds to one input. So this is one-to-one, okay? We cannot have the same output for two different input like quadratics. Quadratics, we can have -1 squared and 1 squared, both equal to 1, okay? In this case, we don't have to consider that. In that case, we can just drop the 4 straight away, okay? Does that make sense to any of you?
Mhm.
Okay. But in quadratics, we got to consider, oh, plus or minus two different solutions. In this case, drop the power. We don't care. X equal -5. Is that what you guys got? Yes, it is, I think. All right, and then we have F, G, H. What did you guys get for H?
1 over 8.
Anyone else?
I think I got that as well.
Okay. So, Adriana, did you get it? Or are you confused about this one?
Yeah, I didn't do it.
Okay, all good. So first of all, convert the left one to a power of 3. All good?
Hmm.
Adriana,
Yeah.
I'm focused. Say yes if you get it, Adriana, okay? Because I'm explaining this one for you. So yes,
Yeah.
and breaking up the 9, making the 9 into 3, 2. Yes?
Yeah.
And then using the formula, we multiply these two. This becomes, okay, I probably shouldn't skip the step, but this is 3 1/4 equals to 3 of 2x, right?
Mm-hmm.
And then you have 1/4 equal to x. X equals 1/8, right?
Oh, okay.
Yeah. So from here to here is just divide both sides by 2, okay?
Yeah.
Yeah. When you have 1/4 divided by 2, this is 1/4 times a half, 1 over 8, right? Or
Yeah.
you can just simply think about it. We slice a pizza in 4 pizza slices, but we want to make each slice two times smaller. Then we slice it into 8 slices, some things like that, right?
Yeah.
Okay. You eat too much pizza. You should know this.
Okay.
All right, I. What is I? Um, Adriana, what did you get for I?
Oh, -2.
Maybe. Let's see. Let's see. Convert both sides to a power of 5. This is 5 to the power of -1 to the power of x. And this is 5 to the power of 2, 5 squared. So we have 5 multiply. Remember, always multiply that formula, right? It's always about those kind of the formula we did in the beginning. Once you understand the formula, you can just use it on negative power, fractional powers, whatever you want to do. So negative x equals 5, 2. Yeah, negative x equal 2, x equal -2. Nice. Any questions? Anyone else?
No.
Lastly, J. Any contestants?
I got 3 over 2.
Nice, that's correct. Anyone? Did everyone else got it?
Yeah.
Hmm.
Okay, so you break up the square root. You put the square root as the power of a half, and because it's multiplying, we can add the power. So obviously x is 1.5 or 3 over 2. Okay? 1.5, 1.5, or 3 over 2. All the answers are fine. I prefer these two. I don't like mixed numbers. All right, any questions before we move on to part 2? No questions? All right, we move on to part 2. So same thing. Okay, I think I'll give you guys a time limit because I feel like we were kind of a little bit slow with the first ones. I think for part 2, I reckon 10 minutes in total, 2.5 minutes each. Give yourself 2.5 minutes for each questions. If you get stuck, just move on to the next one. But it shouldn't be too hard. It should be the same. It tells you, even gives you a hint. It says convert to the same base, right? Convert to the same base and then solve. All right. If you guys are all finished, you can tell me in the chat. Otherwise, we'll start explaining the questions at 4:50. Does that sound good?
Yeah.
Okay. How's everyone finding the questions?
Okay.
Michael, I finished.
Yep. Nice,
Um,
nice. Okay.
I'll be back in a bit because I gotta go downstairs to eat.
Yeah, sure. How
Uh,
long?
it'll be pretty quick, like
So do you want me
5 minutes.
to wait for you? 5 minutes? It'll be like
It's
5, 10.
or 10 minutes. You don't have to wait for me.
Okay, in that case we can have an early break and then yeah, that'll be like fit right in.
Okay.
Okay. All right, Adriana and Hannah, which one are you guys up to?
I'm done as well.
Oh yeah, okay, Hannah.
I finished.
Nice, nice. All right, then in that case, let's just explain. Ryan, when he comes back, he's gonna see it. All right, so what did you guys get for first question?
I've got 7.
Hannah.
Same.
Okay, so for 4, you converted it to half 2, right? And then and then keep everything the same. Keep everything else same. And 2, 2, and then x minus 2. In that
Mhm.
case, we multiply the right-hand side as again. We do the same thing. We expand the bracket and bring the 2 up. So it's 2x minus 4. Okay, so this is like solving algebra. It's not really intuitive. It's just solving exponentials using the power rules. And we can drop the power once again. And then subtract both sides x plus 4, x equals 7. Okay. Uh, not Adriana, Hannah, there's something I want to emphasize. I did this to Adriana. I did this for Adriana. So when we solving this kind of stuff, right? Um, she had a habit of like trying to get to the answer straight away. It's not like skipping steps, it's just trying to get the answer straight away. But most of the time, especially in math, we don't get to the answer straight away. So one suggestion I made was that you might not say the answer straight away, but you want to make sure each step is always correct, right? It might not bring you to the solution, but you are never wrong. Okay, that's the it's wait, I need to find this book. There's something I'm looking for. No way, this book is not in there. Oh my. Oh, found it. Have you guys heard of The Art of War? Have you guys ever heard of this book? The Art of War.
No.
This is so famous in the meme. Oh my, The Art of War. Hannah, have you heard of it?
No.
No way. It's such a famous book. Okay, so there's one saying in the book. There's one saying in the book that says, I don't know the proper translation. You know what? Maybe I'll find the proper translation. Okay, this is actually relevant to the class. Okay, so yeah, that was the Art of War. Uh, English. Okay, but this is a direct translation, but Art of War, know your enemy, quote. Okay. If you know the enemy and know yourself, you need not fear the result of 100 battles. This is a very weird translation. Okay, but the original translation says, it doesn't say if you know your enemy and yourself, you will win. It says you will not be defeated. Okay, this is very important. So this is the same when we are doing this math question. So I said to Adriana, if you always do something to both sides, know why you came up with each step. You might not reach your result, but you are never wrong. This is like the same quote as what we just had. It's like know your enemies and yourself. It's not you will always win, but the best thing you can do is not always win. You will never be defeated, and that's all you need. So you will never get to a wrong line or get to a wrong result if you just keep doing that. So how do we do that in math, right? The key here is just to not jump to the answer. Just do something to both sides. That seems logical, right? In this case, we could subtract x to both sides, right? Although that might not bring us to the answer, right? The x cancel out, and then we have x minus 4. Sometimes it brings us closer to the answer, but sometimes that brings us further to the answer. But the equation itself is still the same equation. You are never wrong. Okay, does that make sense, Hannah? And in this case, it's quite obvious that we just say plus 4, and the 4 cancels out. We have x equals 3 plus 4. We get x equals 7. Adriana, remember this?
Yeah.
Yeah, see, never wrong. All right, give me 1 second. All right, cool. What did you guys get? What did you guys get for B? I reckon it's pretty much similar things.
1.
Adriana?
1.
Okay, nice. I'm not even gonna do it. 1 minus 3. This is 1 minus 4. So you're saying 2 to the power of negative 5 is 25 to the power of negative 3. Or both of you got 1?
No, I got 5.
Oh, 5. Adriana, what did you get?
Wait, which one? Oh, I got 5. I was looking at C.
Okay.
C is 1, I
Why
think.
does it sound like conspiracy?
Oh, C is 1, trust.
Okay. 5 is you got 5? I'm not even gonna do it. I'm just gonna test if it's correct. 5 squared equals 25, 1. Okay. That's correct. So the 5 is correct. I'm not doing it. Right now I'm just verifying, okay? Because you guys, since both of you got the same answer. You said 1. 3 times 1 minus 5. So we're saying this to the power of negative 4 is 36 to the power of negative 2. Oh, that is correct. That is correct. Okay. This 1 to the power of 6, 4 equals 1 to the power of 36 squared. That's correct. Okay. So yes, 1 is correct. Hannah, you got 1 as well? Yeah?
Mm-hmm.
Good job. For D, what did you guys get?
Negative 5 over 3.
Hannah?
Yeah, same.
Okay, so you want to convert to the same base. In this case, maybe convert it to 3. So 3 squared is 9, right? Copy everything else. On the right hand side, we have 3 to the power negative 1, and then copy everything else. And then again, we want to keep the base 3. So we expand the bracket. This becomes 2 times 5, 10x plus 6. This is negative 1. Oh, 11 minus x simply becomes x minus 11. Oh, quick tip here. So a minus b, if we have something in the form of a minus b, if we want to multiply by negative 1, this is, oh, okay. If we have a minus b and we want to multiply this by negative 1, this is simply b minus a. Okay, swap the order. Why is it true? Negative b becomes positive b. Okay, positive a becomes negative a. Okay,
Okay.
all right, cool. So just a quick math tip. And then x minus 11, same thing, 9x minus 17. Am I choking? Am I tripping? Oh, I am. I copied the question wrong. This is 2, so this is 4. Minus 15, so you guys got minus 5/3.
Yeah.
Nice. All right. Do you guys want a break or do you guys want to do some more practice before the break?
I don't know. Break.
Hannah, who do you vote? We only get one break, so it doesn't matter. If you guys doesn't feel like breaking, you can keep going.
I don't mind.
All right, let's do one more. Okay. So this will be easy. This will be calculator pressing. So kind of easy. Because last time you guys didn't really get the exponential part, right? I just want you guys to know what this means. Hannah, I went through this part with you on private lesson, right? Did I or not?
Um,
I'm not too sure if it's you or Ryan.
I don't think it was me.
Okay, then it was Ryan. Okay, yeah. Yeah, just fill out the table. Fill out the table. Just fill out the table and then we're done. Use calculator, okay? It takes about, I think it'll take about 2 to 3 minutes because you're gonna be pressing calculators, and it will be 2 to 3 minutes, 5 o'clock, and we'll be back at 5-6 minute break. We'll be back at 5:10. No, 5:10 is too much. 5:07 sounds good. Okay. I'll be wearing my headphones, so if you guys have any questions, you can still ask me anytime. But in the meantime, I'm just gonna wash some dishes and take a break. All right, how's everyone doing?
I'm done.
Okay, nice. Enjoy the break then. Um, but if there's any questions, ask me. I'm always online. I'm just not in my camera. Or we can chat if you want.
It's okay.
Wait, do you want to hear me play piano?
Um,
I don't even know if the mic can if the mic can capture me. Alright, I think I'll play something. If you guys can hear it, you can tell me. If not, then doesn't matter. I'm not too sure. Let's see. All right. Do you hear it?
No.
no.
Oh, wait. I heard like a note.
Yeah.
Yeah.
No.
I think it's because it's like wait, I need to do some auto setting. Is you separate audio device volume automatically adjust headphone. Okay. Adjust microphone volume. Hello. Do I sound more quiet now, or is it the same?
A little more quiet.
Okay. Okay. All right. Try again. See if you hear anything from the piano. Okay. Anything?
Yeah, I can slightly hear it.
Slightly. If I play something uh like this, do you hear anything?
No.
Okay, then it doesn't work. Okay,
No.
Ryan, did we go through this investigation in class? In
No.
our class? Oh, I
No.
remember going through this with someone, but I can't remember who it was. It was either you or Hannah.
Oh, wait. We did.
We
We
did.
did.
Okay, okay. But this is not easy. So yeah. Right now I just told everyone to fill this table using calculator and then uh and then we can break. How many
Wait,
minutes do we have?
what was this formula used for? Because I thought it was used for.
Exponential.
Oh,
E, the natural number E.
damn. Because I thought it was used for compound.
Yes, compound is related to natural number E.
Oh,
Yes, they
okay.
are related. Oh, by the way, Ryan, have you heard of the art of war?
Yep, I have.
Nice. I was just explaining to Adriana and Hannah, but they didn't hear of this. Do you know the Chinese? Do you know the Chinese name?
I know the person who wrote it.
Okay, so basically just saying in there, if you know your enemy and yourself, you will never be defeated, something like that, right?
Oh, yeah, I know that quote as well.
The
Yeah.
quote does not say you will win, it says you will not be defeated. And I was talking about this concept in math. I was like, when you solve a question, right? You gotta know at each step what you are doing. You might not reach the right conclusion, but your formula or the conclusion or the part of the conclusion that you come to is not wrong.
Cool.
Okay, I was using that quote. Like you will not win, but you will not be defeated. So you will not get to the solution, but you will never be wrong. Does
Okay.
that make sense?
Yo,
Interesting, right?
Sun Tzu in math
Yes.
is crazy.
All right, everybody, are we all back?
Yeah.
Yeah.
Adriana? Okay, Adriana's not back. Well, I think we'll wait for 1 more minute, otherwise we'll start. Adriana, are you there? Okay, I
Oh
think she
yeah,
is
I'm
back. All right, so maybe anyone just shout out anything, shout out the decimal place, shout out the numbers for these. Just like everything at once.
Two.
2. Keep going, just all the way.
9/4.
2.25, okay.
2.3704.
2.3704, okay. 5 decimal place, but is this exact? Maybe it is. No, there's no way it's exact. 5 decimal place means one more, okay?
Oh.
So anyone else?
What are we moving on to 4? Oh,
No, 3. 5 decimal place, technically there's one more, right?
Yo.
This should be, oh, wait a second. It's
what?
04, but it's 037, 037 recurring, okay? 037, okay? What about 4, anyone?
2.44141.
Yes, 2.44141. 5?
2.48832.
10?
I accidentally forgot to put it in 5 decimal places.
No, all good, it's okay. As long as the number is roughly right. This should be 2.59374, okay?
Yo.
And for 100, this is 2.70481, okay? For 1000, is 2.71692. For 10,000, anyone for 10,000?
Um 2.71815.
Yes, nice. What about 100,000?
Like 2.71827.
Nice. So rounding to 5 decimal place. Any questions for these?
Wait, why do you round to 5 decimal place again?
No particular reason.
Oh,
Just just round it to a certain accuracy.
okay.
So any questions before we move on to this? This is where the natural number e comes from. Okay, this constant, approximately 2.17 is, sorry, 2.71 is the natural number e. Okay, we call it a natural number because it weirdly appears in the nature. Okay, some people say it's a scam. Some people say nature doesn't have this number in it, but this formula does. Okay, because nature has a lot of compounding, like how germs grow, how trees offspring they grow, right? All the compounding can't be modeled by discrete time, can't be modeled by like 1 year, 2 year, 3 years. It keeps growing every single second. And this is a model that simulates something that keeps growing on a very small rate, but at a very small time interval. And this is time E, okay?
Mhm.
So this is where natural number comes from. And I would like to introduce another concept, which is interest rate. We did this last time, but I think I really rushed through it last time. So this time I'm just gonna go slowly. Okay. All right. So let's say we have 10% interest rate, annual interest rate. Okay. So after 1 year, how do we calculate the money in the bank? Let's say we put in $100. After 1 year, how do we calculate the money in the bank?
Wait,
Anyone?
is this simple or compound?
Just 1 year, simple. Yeah.
Oh,
We get paid at the end of the year.
it really doesn't matter anyways. Like 10,
Yeah.
you get 110.
So you use 100, yes, multiply by 1.1. So 1.1 comes from 1, which is the base, plus the 10%, right? This is 1.1, 110. No questions?
No.
Okay. So now I'm saying, what if we get paid every 6 months? This is the same thing last time, but I'm gonna go more slowly and then explain in more detail. So we get paid every 6 months. That means at 6 months we get paid $5, right? And at the end we get paid $5, right?
Mm-hmm.
So this becomes 105, and then it becomes 110. But wait, the catch here is that we have this $5 spare. Why don't we reinvest this $5 again? Okay. So from 100 to 105, this is actually 5%, right? So from here to here, rather than plus $5, why don't we plus 5% again? Meaning that we reinvest this $5 altogether with the $100. So here, to get wait, sorry. So if we reinvest this $5, right? We have 105 that enjoys the 5% extra interest rate for the second half of the year. And in the end, we get paid a little bit more than what we have in the beginning. Does that make sense? So this comes from 105 times 1.05. Or in other words, this is 100 times 1.05 to the power of 2. Does that make sense to everyone?
Mm-hmm.
Adriana and Hannah,
Yeah.
Yeah.
are you guys sure?
Yep.
Yeah.
Okay. So instead of plus 5, plus 5, plus 5, we do 5%, 5%, 5%. So this is the idea of compounding, right? Within the same time interval. We are compounding within the same time interval mm, because if we compound over 2 year, 3 year, that's simply way more than 110. We want to compare. This is one payment, right? This is one payment. We want to compare the difference between one payment and then payment. And maybe here we can have 12 payment, right? So here we are compounding every month. The next example that we're going to do. Let's say we paid monthly. Let's say we paid monthly. The first month, the interest rate is 10%, right? So the first month, we're gonna get something like 100 times 1 plus 10%. But wait, we're getting paid monthly, so it's 10% divided by 12. So this is roughly 1.083, okay? So the first month we're gonna have, oh sorry, 1.0083. So in the first month, we're gonna have about 180 cents, something like that. And after 12 months, we're gonna have about 110, right? But remember, we're not adding 0.83 here. We are actually multiplying by 1.0083. So in the next timestamp, we're gonna have we're gonna have 100 times 1.0083 to the power of 2. This means in the second month, we are compounding twice again, okay? And that will give us, give me 1 second. That will give us 101.67, okay? And then all the way to the end, how do we calculate everything in the end, right? We're not simply adding this interest. We are reinvesting interest constantly when we get them. So in the end, the formula is this. Is 100. We have how many times we have invested? We have invested 12 times. So it's the interest rate to the power of 12, right? How do we calculate each interest rate? This is the same thing. It's the 083, but yeah, it's this. Okay, it's the 083, but with the calculation from 10% divided by 12. So we are breaking up this interest rate, but we are compounding this number, okay? So this is the number of period. 12 is the number of period. And then we are making the number period shorter and shorter, but we're increasing the we're increasing the number of period, but we are making each period shorter and shorter. And in the end, this turns out to be, give me 1 second. I'm gonna do some calculators. Pressing. This gives us, oh, not even that much, 110.47. So turns out we get like half a dollar more than whatever this is, and maybe 25 cents more than this. But that's still more money than what we originally have, right? So this is the idea of compounding. And in this case, this is where this formula comes from. Does that make sense to everyone?
Yeah.
Hannah?
Yeah.
Okay. And when we are using that formula, especially in the bank, we kind of like to use the letter E instead because we know it's like infinite compound, right? So when we calculate the growth rate of something, rather than saying, let's say, x1 for like the money we have at time equal 1. This is x0 times r to the power of something, r to the power of n. Rather than saying this, we like to use exponential because exponential offers us a more continuous growth, and it is more than this hardcore calculation. We like to use something like this, E, N, T. We do something like this. Wait, no. E to the power R times T. I should use T here. Okay, where R is the interest rate, T is the number of compounding period, or like the time interval. You don't have to know the detail of this. When you get to it, you'll know. This is to do with calculus because you use this when you make the time interval very, very small, and that's a calculus concept, okay? Right now, I just want you guys to know what E means and what this formula means, where this comes from. And I believe you guys know that right now, okay? Any questions before we move on to other questions?
No.
Cool. In that case, I'm gonna find some more general exponential practice for you guys. Okay, this is exercise 9E. Let's see if we can find an interesting one to do. Okay, this is a question I believe we did discuss this question like briefly in the end last time. It's very hard, but give it an attempt. It's not as hard. It is not as hard as you think. Okay, you don't really have to understand the formula, what the formula means to do this question. You just have to substitute. Okay, so I think take 2 to 3 minutes, give it a try. If there's any questions or if you get stuck, tell me, okay? Also, you can use calculator for this. All right, how's everyone doing?
I just don't know what E is. Like,
Oh, E is the number we just did.
oh, oh,
It's just treat it as 2.17. But when you press calculator, there's a key on the calculator. There's like a handwritten case E.
oh, yeah,
Yeah.
okay.
Yeah. Ryan and Hannah, how are you two doing?
I finished.
Okay, nice.
I'm almost done.
Okay. Tell me when you're done. This is like pi, okay? So if you're confused, just treat it as a number. It's just 2.71. It's a constant, it's a number, okay? All right, Hannah, are you done?
Yeah.
Okay. All right, Adriana, how are you doing?
I'm almost done.
Okay, cool. Ryan, what did you get for the first part?
4,500.
Nice. Adriana, did you get the same thing?
Yeah.
Yep, so this is a function, right? Remember a function takes the input and gives you an output. Okay? In our case right here, the input is time. Um, uh, time after t days, right? Input is t. And our output is g, is the area. Area in centimeters square. And because we have this function for part A, for part A, we could just substitute t equals 0 because that's the initial area, t equals 0, right? G of 0 equals 4500 e to the power of 0 0.t times 0. So this e to the power of 0 just becomes 1. Remember, anything to the power of 0 is 1. You get 4500. Okay? And anyone for the second part?
I got like 90,000. Wait.
Okay. Hannah?
I got 90384. Wait,
Okay.
385. Well, rounded.
Yep. So basically, after 10 days have passed, we just substitute t equals 10 in, right? Adriana, how are you doing with this one?
I did that. Yeah.
So same answer?
Yeah.
Yep. So putting everything into calculator, this is roughly like 45,000 times 2.7 to the power of 3, right? So expecting it to grow approximately like about from 10 to 20 times, because 2.7 to the power of 3, this is about, I'll say 20, right? Let's see how that's just an estimate. Yeah, it is 20.08. Oh my God, how did I guess it so accurately? Yeah, so if you put that in the calculator, we realize the after 10 days, the gym or whatever it is,
Isn't it a fungus?
fungus, I don't know, fungus is type of gym, I don't know, has 20x its area. Okay, it's approximately 20x area. All right, any questions? Adriana, did you get it?
Yeah.
All right, cool. That's the only exponential question that I'm gonna let you guys do because, yeah. Okay, so quick note here. 0.3 here is like the parameter of this function. We model the rate of growth, but how do we model like how fast or how slow it grows, right? Not all of them grows at a rate e. So it's going to be e something t. That something is going to be the parameter that tells us how fast it grows. Okay. All right. If you don't fully get this, it's okay. This is not that important. You just have to know how to use the function. All right. We are 30 minutes away. Let's just introduce the concept of inverse functions and logarithms. How exciting.
I'm so excited.
What?
I said I'm so excited to learn logarithms.
Nice. Okay. Okay, I'm looking at the practice questions. Which one is a good practice question for you guys? Oh, nice. Okay. This is good. All right, before I do logarithms, wait, why can't I share? Oh, what is wrong with my screen share? Okay. Before I give you the practice questions, I'll quickly introduce what logarithm is. All right, since Hannah have done this, I'll give Hannah a little small question. Uh, if I say x equals base a, log base a b, what does this mean, Hannah?
A to the power of x is b.
Yes. This is used to solve a to the power of x equals b. If I tell you, if I tell you 3 to the power of x equals 81, guys, what is x? Sorry? Anyone?
4.
4, yes. If you have a calculator with you, try to put this in the calculator. That's gonna give you 4. Okay? Actually, yeah, try to do that. Try to do that and tell me when you guys are done. All right. Did it
Wait,
work? Is it 4?
Mr. Michael, how am I supposed to put the base in on my
Oh, okay. I just realized something. Some calculator doesn't have a base. So, okay, in that case, we can't put that into calculator. I'm sorry.
Wait, what do you mean a base?
because this base 3 matters. Like the base of log
Oh,
actually matters.
damn.
But yeah, I believe some calculator doesn't have it. My calculator doesn't have it, so we need to use some different ways. It's okay. Before I move on to wait, yeah, I can't be bothered explaining that part. Okay, let's just introduce to you what log means. Log is the inverse function of power bracket exponentials. Okay? So let's say, remember functions is always input output, right? Let's say your function of x equals to let's say 2 to the power of x. Okay? And I could give you an example. Maybe anyone tell me what is f of 3?
Wait, what?
8.
8. Nice. Ryan, did you get it?
Yo.
Adriana?
No.
No.
Wait. What is F again?
F is a function. Did you come to the function lesson?
No.
Okay, that makes sense. Okay. So f is a function, takes an input, gives you an output. And this fx is like the name of the function is fx. Let's say the name of me is Michael. This is the name of the function. And it tells you the function is defined as this. Okay. This equal sign doesn't mean equal. It means define. Okay. This function is defined as this. Okay.
I,
So when I put 3 inside, we put 3 inside. This is 2 to the power of 3, which is 8.
oh, okay.
Okay. Tell me what about f of -1?
Wait, I don't understand where like the 2 comes from. Like, I don't.
Oh, I define it to be like this. It's f is a name. I'm saying this function is this. I'm literally throwing you this expression. There's no where it comes from. It's like I'm saying solve this question. Now I'm saying, okay, give you this function.
Oh,
Okay, I'm throwing you this question. It's
oh,
like
so
yeah,
that one, the next one is 0.5.
nice. It's a 2 -1, which is a half or 0.5. Nice.
Okay.
Okay, I'll give you a slightly more tricky one. What is f of a?
2 to the power of A.
Yep, when it's an unknown, keep it an unknown. Okay, nice. Um, I believe we briefly did the composite functions. So Ryan and Hannah, can any of you tell me what is f of x?
Wait, what?
Hannah, give it a try.
Wait, do you put 2x in the bracket?
Okay, yeah, good start. F for 2x in.
And then um 2 to the power of 2x.
Nice. Quick question. Does
Um,
this equal to 4 to the power of x?
Wait,
mm,
12x. What?
Yeah, just a quick question. I'm asking, does this equal to this?
yes.
No, it doesn't. Oh my, this is such a troll. Okay, why does it not equal to that? Okay, we know the formula is this, right? Remember the formula is x to the power of a bracket b equals xab, right?
Mm-hmm.
But x to the power of a b, if this is the bracket, if this is like that, this cannot be simplified. Okay?
Okay.
Only if you have xa as a whole, then this can be simplified. If it's this, no, it cannot be simplified. Okay? This b is too powerful. It's increasing a exponentially, and this is increasing x exponentially. So this cannot be simplified. You just gotta leave it like this. Okay? And there's even a concept in math that's called, I don't even know the name is called. let's say you got multiply, multiply, you got addition. Too much addition becomes multiply. Too much multiply becomes exponential. What happens if you have too much exponential? This is called, you put it on the left. We don't even have this in uni math. I don't even see a point of this, but you put it on the left. This is so weird, right?
Goof?
Huh?
What the goof?
I don't know what this is, but like if you have two exponentials stacking each other, you put it on the left. Just fun facts, okay? Just fun facts.
And you don't even see this in uni, so there's like no point.
Yeah, you never use this, just for fun.
Okay.
Yeah. Yeah, anyway, the point of this, I was telling you that, okay, remember what inverse function does. Inverse function is a thing that will give you the input when you feed it the output. For example, in the case we just did, the inverse function will throw you you put 0.5 in, it's gonna give you -1 back. Okay? For the inverse function, you put 8 in, it's gonna give you 3 back. We wonder what is this inverse function? And now I tell you this inverse function is log base 2x. Okay?
Yep.
And what does this mean, like intuitively? Okay, everyone listen up, listen to this sentence. It's very important. Log base 2x means what power of 2 will give you x? Okay? Which is precisely the inverse of this. This asks you what power of 2 gives you x. Here x is your x of course is your output. Here your x is input. There's just different names. If it makes you guys more comfortable, we can do something like this. We can do something like this if it makes you guys more comfortable, because the ideal function is not easy, and I can see why this could get confusing. So if it's more comfortable, you could write this. You could have x equals log base 2 y, like this. So your y is like your fx, your output. Okay. So log means what power of 2 gives you y, and of course 2 to the power of x gives you y. Okay? Does that make sense?
Yep.
Yeah.
Adriana,
Yeah.
are you sure?
Yeah.
Okay, let's try to do some practices, okay? With that said, I think we're going to spend the next 20 minutes on some basic logarithm practice and maybe potentially some logarithm formulas, okay? So log is not hard, it's just opposite or inverse of exponentials, okay? All right, so do question 1, write the equations in exponential form. Okay, before you guys do it, before you guys like get into it, just do question A. Try to do question A and tell me what do you get for A.
What the goofy?
Wait
That's
for
okay.
one.
1A, yes. It's gonna be easy for you, Hannah.
Do you want me to
Right?
type it? Or
Yeah, just type it. Yeah, it's gonna be easy for you. But I want to see how Ryan and Adriana catch up on this.
Yo, someone tell me the answer, please.
Yeah, I don't know.
Uh,
Okay, give it a try. I'll give you like 30 seconds. Give it a try.
wait, so Michael, it's
Mm-hmm.
what of P gives
Mm-hmm.
you R, right? Or is it what of P gives you Q?
Gives you Q. Remember, what of
And
P gives you R is gonna be the same thing as this.
so
So it's not that.
R is what you get when you do what of P gives you Q.
Yep. Nice. Yes.
And an exponential form. So what?
By the way, Hannah, yes, that's correct. Yeah. Okay, say it again. What power of P gives you Q?
Is it not just P to the power of Q?
What power of P gives you Q? What power of P
Oh,
gives you
P to the
Q?
power of R.
Yes, that's it.
Oh, what the
That's it.
spit, bro. Oh my God, I'm so blind.
Adriana, do you get it?
Wait, can you explain that?
Just one sentence. Log. You have a base, right?
Yeah.
Here we have log P and Q. So log P is a function, right? Log P is the function. So log P is a function. Like sine, cos, tan, like all your functions, the calculator, the
Yeah.
calculator helps you compute it. And Q is your input.
Yeah.
And what does the function give you? The function gives you this. Okay, listen to this sentence again carefully. It's the same sentence. The output is what power of P gives you Q. Okay,
Mm-hmm.
that's what I was stressing about. What power of P gives you Q? If you read that like 10 times, you're gonna get what it means.
Okay. Okay.
So try question A again. In the meantime, Ryan and Hannah, you guys can type B all the way to E in the chat. Just do question 1 in the chat, okay?
Wait, Michael, for B, is it not like basically the exact same? Don't you
Oh, they
just
are all exactly the same. Yes. Just for you to get the concept.
Oh,
E to the power of R equals Q. Nice. Nice, Adriana. That is correct.
damn. This is okay.
Hannah, you don't want to have log, right, Hannah? Hannah, you don't want to have log
Oh,
in your
right.
equation. So, in my opinion, I just remember this. I just remember this sentence, and then I'm all good for log.
You're okay, log is not as hard as I thought it'd be.
Yes, easy.
Currently,
It's
currently.
just a mind twisting. It's not, yeah, it is not hard. It is, in fact, very easy. What's hard? I reckon like the hardest topic in high school, imaginary numbers is definitely one of the hardest one. Imaginary numbers. Uh, Trigonometry is not easy. Uh, Quadratic is not easy. And beyond all of that, you have calculus. So calculus is definitely the hardest, but it's not that hard. It's doable. All right, Adriana's popping off.
Wait,
Oh, yeah.
for these ones, you want me to give the actual like number?
No, 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 you don't have to. Just express it in the exponential form. Yes, what you are doing is good.
Wait, how would you do E, Michael? Because isn't it just
Oh, okay. Oh, interesting question. Good question. How do you do E, Hannah? Do you know?
Yeah.
How do you do E? Explain. Explain to everyone.
If there's no base given, it's just base 10.
Yes, that is correct.
Oh,
base 10?
Because as humans, we are always interested in powers of tens because we have 10 fingers and our number go up in tens. Okay. Because we count in 10 fingers, so that's why we go up 1 digit every 10. And that's actually so true. If you see an animal with 6 fingers, they're gonna go up 1, 2, 3, 4, 6, and then 11, 12, 13, 14, 16. And then they like the largest 2 digit number they're gonna have is 66. It's called like I think it's called binary, and then I don't know what it's called, but like how many numbers you go up every
Oh,
digit.
okay.
Did
Oh
you
no,
learn
I
that in
think
talk?
we do talk about it in talk, but it's a very interesting idea.
wait.
Because yeah,
Do
why?
you remember this rule? Is it like, will we be all set? Like,
Yeah, you're all set.
okay.
But there's more rules to that, not just one. That's the definition of log. It's like the definition of exponential is you multiply a number of stuff altogether. Okay?
Yeah.
But this is very important. Log means what powers of the base gives you the top number. And yes, all the answers you send me is correct. Ryan, you should send 10 to the power of x equals 11, not not equals e.
Wait, did I put E?
No, for all the questions you said, you should like say equals whatever, equals whatever.
Oh, okay. Got it. That is Q.
So yes, I get how you're trying to solve the question, but like the question asking you to like convert it into the exponential form, you don't have to solve it.
Sure.
So for example, for example, for B, you should say 3 to the power of R gives you 5, right? For C, you should say 7 to the power of 6 gives you Q. And yes, Q equals whatever number it is. And for
Okay.
D, you should have P to the power of 3 gives you 5. So it's not asking you to solve it, it's just asking you to,
Turn it
yeah,
into.
yeah. And for E, base 10, so 10 to the power of x equals 11. Okay, I get how this could be a little bit counterintuitive and it's pretty easy to make mistakes, but as long as we stick to the definition, we're chilling. Okay. All right, so now we have question 2, write each equation in logarithmic form. Before we do that, I'm just gonna tell you guys some basic concepts for this. Okay. So some basic formulas, not even the formulas, just the basic ideas of log. Let's say with log base 10, 1. What is this equal to? Can anyone tell me?
49 p.m.
It is not equal to 49 p.m.
No, that was my watch, my bad. Um,
0.
Oh, yeah.
Yes. Why does it equal 0? Anyone explain?
Because 10 to the power of 0 equals 1.
Yes. Because 10 to the power 0 equals 1. And in fact, anything to the power of log anything base 1, this is 0 because anything to the power of 0 is 1. Okay. Um, some interesting ideas. What about, let's just try another very numerical example. What is log 2 8? What is this? We did this before, like a few minutes back. What is this?
3.
3. Nice. Okay. And what about log base, let's say 10, 10. What is this?
1.
1. Ryan and Adriana, do you guys get it?
Yeah.
Okay, Adriana, try to do this.
wait,
What is,
Michael, how would you do this in a calculator? Like,
oh, good question. Calculator, the default log is base 10, okay? If you go on your calculator, press log 10, this should give you 1, I believe. Try that.
Oh, I just did like 10 to the power of 0, but like to get 1 for that one.
For
oh,
this?
Yeah.
Oh, but this one you are like, you know the answer already. You're verifying the answer, so so you don't need to put this in.
No, I mean like
Technically,
the
hmm,
green, like 10, 10.
this
Yeah.
10 to the power of 0. No, this is not related to 10 to the power of 0.
Oh,
This is
okay.
two separate questions. This is two separate questions.
yeah.
So you want to put that in. You want to put log 10 10, see if you get 1.
Wait, how do you get log 1010? Because mine is like log open brackets.
Yes.
Yes, by default is 10. Because default is 10, so you don't have to put the base in.
Oh, yeah, there's one.
Yep, okay. Now the next question is how do we get default base 2? There's a rule. There's a rule called base changing rule. Okay, this is a very powerful rule. If you know this, you don't have to use your brain in log questions anymore. Base change rule or base swap. Is it called base change or base swap, Anna?
Base swap.
Base swap.
I'll go write this down first.
So if you have log base A, B, this equals to log any base you want. Log any base you want. For B on the top, for A on the bottom. It's even easy to remember. A is already on the bottom, B is already on the top. Okay? So technically, if you want to put the log 2/8 in the calculator, this is log anything 8 over log anything 2. Okay? Try that. Try that with your log.
Wait, what is K?
Anything. Oh, sorry, the bottom one should be K. I
Is it
miswrote.
3?
Yeah, you get 3. 2 to the power of 3 is 8, right?
Yeah.
K is anything you want. Anything works. That's the most powerful part about this rule.
But how do you get K as the base?
You don't want, if anything works, pick whatever base you want. In this case, you can only put log 10 in there, so just put 10 in there. Right?
Okay.
Any K works. Now, to be precise, any K bigger than 0 works. Tell me when you get 3. Does it work, guys?
Yeah.
Um,
Mhm. Yeah.
All right. I guess we move on. The next important thing I'm gonna briefly tell you guys is that since log is related to exponential, and exponential we have the natural number e, then there must be a, yeah, we always get like y equals ex, right? And what is the inverse of this? Ryan, oh Ryan, did you get that? Did you get this
oh
part?
yeah, I did. I got 3.
Okay. All right. Ryan and Adriana, not Hannah, because Hannah, I know you know this. How do you represent this in terms of log?
Wait,
Is it like log E? No, I don't know.
It's log something,
Michael,
okay?
is log on the left side or right side?
Doesn't
Because
matter.
Is it log E
It's something equals something. Yeah.
X?
Sorry, what is it again?
Log E Y equals X.
Exactly. What power of e gives you y? X power of
oh,
e gives you y. Or e to the power of x gives you y. Okay? Since we have a lot of e to the power of something in real life, we're gonna have a lot of log e in real life. And this thing has a special name. Natural log, ln. Y equal x. Ever seen ln in your calculator? That's what it means. Right next to the log key, there's a ln. Do you guys see it?
oh yeah.
Mm-hmm.
lny. All right, cool. Hannah, you okay with all of this, right?
Yeah.
Yep. Since ln is your natural log. Oh, by the way, Hannah, you did your exams, right? How was it?
No, it's just a test.
Oh, yeah, how was the test?
Oh, it's okay.
Oh, okay, okay. We'll see, we'll see. Yeah, once you finish, we can go through the test.
Yeah.
Yeah. Yeah, also, yeah, for this is for all of you. If you have school test, one important thing is that you bring the test back. For the questions you got wrong, we can go through them because those questions in the test, you'd be like, oh, how do I do it? How do I do it? When you actually think about it and when you know the answers, it's very strong reinforcement learning. Okay, so when you get a test, bring it back and we go through it together. Okay. All right. Apart from that, yeah, let's just say ln is log e. Then there's some interesting things we can do with it. First of all, ln e. What is ln e, guys? Ryan and Adriana, one of you tell me.
1.
Nice. Why?
Um, because they cancel out.
Technically, yes, but the reason behind it is like log e. What power of e gives you e? E to the power of 1 gives you e. Okay.
Okay.
You following, Adriana?
Yeah.
Okay. What about this is harder. This is harder. What about e to the power of ln x? X is a variable. Anything. What is this?
What the goofy. Wait, let me write this down.
Maybe this is too hard. But this
Wait,
is definitely like
no,
kind
I
of hard.
believe. I believe.
Yeah.
Is it 1?
No.
Oh. Is it 0?
No.
Okay, well.
Wait,
Good guess.
Wait.
Good guesses.
wait. Oh, is it the number, the variable? It's x. It's
It
x.
is X. Nice. Nice. How do you get it?
Well, if you think about it, so there's e, and then there's ln, and there's like e on the bottom.
Yeah.
So, and also originally that just gives you 1, right? And I just like thought 1 multiplied by the variable would give you the variable. So,
Uh. Okay, that's not a proper thought process. There are two ways to think about it. One is to grind it out in your mind. Be like, okay, ln x means what? It means what power of e gives you x, right? That's let's say, grind it out in your mind. What power of e gives you x? And you apply that power to e. What's that gonna give you? X, right?
what the goof? Okay.
Okay, guys, this is this again, especially Adriana and Hannah. I think you get this, right? So ln x tells you what? ln x says what power of e gives you x. Now you know that power. Suppose you know x. That will give you a value that tells you, oh, what power of e gives you x. And you take that power, you chuck it on top of e, you'd be like, oh, e to the power of that. Of course, that's going to give you x because that power comes from that definition. E to the power of that equals x. Okay.
Okay.
I could do it in a more algebraic way. Let's say ln x is, let's say this is k, okay? What does k mean? Um, k means what? E to the power of k equals x, right? Or I could add one more step. So we have log e x equals k. So e to the power of x, e to the power of k equals x, right?
Yeah.
Yeah, so we substitute it back. So we have we are interested in ln x, but we know ln x equals k, right? We know ln x equals k. We assume it to be k, so e to the power of k. But e to the power of k, we proved e to the power of k equals x. So this equals x.
Oh.
This is a very, yeah, brain twisting, but this is the harder way to do it. There's an easier way. But easier way involves more generalization, and that is inverse functions. As I said, exponential and ln are inverse of each other. So ln x is like, if we think about ln as the input to output and exponential as the inverse, the output to input, ln x gives you input to output, and exponential takes it back. So whatever you get put in is whatever you get out. ln x is x. Okay?
Okay.
Yeah, so that's inverse functions. We can talk about more about this in the functions chapter. But yeah, that's what I told Hannah. I was like, the easier way to think about this is because exponential and ln, they are inverse of each other. So you're putting them inside each other. Whatever you put in is whatever you get. So e ln x is x. In the same way, ln ex is also x. Oh, right, 601. That was interesting. We haven't done that much practice, but that was a quick crash course on log. And I guess I'll leave you guys some homework with exponentials and a little bit of logarithms so you guys don't forget log completely. But yeah, it's not too hard, I think. I just hope that the one day when you're gonna learn log, you know what it is. Okay? Because I've done this kind of stuff when I was in high school. I have a math tutor who taught me a lot of stuff ahead, and then I did understand it when I was learning it, but um, I tend to forget them all. But yeah. Like it's gonna come in handy one day, and I don't want you guys to forget it. So I'm gonna leave you guys some homework. I'll send it in the group chat later, but if you do it or not, it's up to you guys. But yeah, any questions before we finish?
No.
All right.
Okay.
All right, in that case, thank you guys for coming, and I will see you guys same time next week.
Okay.
Okay.
Thank you.
Thank you.
Thank you.
All
Bye.
right, laters.